All right, so last night there were certain problems on the homework that you realized didn't have an opposite. So we'll look at one right now. So my question is, how could we create an opposite? Okay, how could we create an opposite? Sophia?
Multiplying an equation by negative 1.
Exactly. All we need to do, because you notice like right here, the a's have the same coefficient. So all I need to do is to get the signs to be opposites. So all I need to do is to multiply one equation, and that's every term in that one equation, by negative 1. So if you noticed, you have the first one we didn't change, but the second one now becomes negative of a, and then minus 10b equals, and then it's going to become a positive 16. Now that we've artificially created the opposites, we can go ahead and add the equations. The a's are going to eliminate. This is going to give me a negative 6b equals a positive 12. And then we divide both sides by negative 6, and we get b equals negative 2. So that's the first one. Then I'm going to take that answer, and I'm going to plug it in here and solve for a. And it doesn't matter which one. So I have a times 4, or a plus 4 times the quantity negative 2 equals negative 4. And then I just keep solving. 4 times negative 2 is negative 8. I'm going to add 8 to both sides, and I get a equals 4. So remember we talked about that when we write our answer, if it's not x's and y's, we do write it alphabetically. So the a should come first, and then the b would come second. So if you have a matching coefficient, but the signs match too, all you have to do is multiply one equation. And it doesn't have to be the bottom one. It could be the top one. It just needs to be one equation is going to get multiplied by negative 1. And that's every term. So this is called elimination using subtraction. But really what we're doing is not subtracting as much as we are multiplying everything by a negative 1 and then solving. So I'm going to give you guys a moment to write that down, and then we'll write down a couple things on the next slide. All right, I'm going to move to the next screen, and we're going to write down a couple things. We'll do one more example. If you didn't finish this screen, then I'll go back at the end, and you can copy it at your leisure. So basically, we have this condition. Do you have matching coefficients come on you on one variable but same signs? So do you have matching coefficients on one variable but same sign? So that's not opposites. We need opposites to add the equations together. So if the answer is yes, you're going to multiply all terms in one equation by negative 1 to force opposites to occur. Okay? So we have the ability to now alter the equations to get that match that we're looking for, which is same coefficient on the same variable but opposite signs. Okay? So all this is called prep, and we're prepping this problem to solve. And then next we would just add the equations together. And continue on the process that we talked about yesterday. So I'm not going to write them all down because we've already written them down. You're going to add the equations together. It will eliminate the variable that has the opposites on the coefficient. You'll solve for the remaining variable. You'll take that value, substitute it into either original equation, solve for this other variable that we had originally eliminated, write the answer as an ordered pair. So I'm not going to write that down. We already have that written down from yesterday. So let's do one more example, and I'll take another one off of the homework from last night. Let's do one that had both. That first example had both positives on our variable. Let's do one that has both negatives. All right, so there was another problem on the homework from last night that didn't have the opposite match. So directions are just going to say solve. We're going to use our elimination to help us. And let's do this problem. 6x minus 2y equals 1. 10x minus 2y equals 5. So again, what we're looking for is one variable where the coefficients are the same and the signs are the same. Okay, so which variable meets that condition? The y's. So what we say, we have that, the y's have the same coefficient, but the signs are the same. I need the signs to be opposite, so what I'm going to do is multiply one equation, everything by -1. So I'm going to, this time, the last time I multiplied this second one, I'm going to multiply the top one by -1. So now that equation becomes -6x plus 2y equals -1. And then we're ready to add our equations together. And then we just start doing the math. So 10x take away 6x is 4x. My y's eliminate, equals 4. Divide both sides by 4. I get x equals 1. I'm going to substitute that value for 1 into either original equation. I'm going to pick it where the x value is smaller. And I'm going to get 6 times 1 minus 2y equals 1. So I get 6 minus 2y equals 1. Subtract 6 from both sides. I get -2y equals -5. Divide both sides by -2, and we get y equals +5/2. So then we take our two coordinates, and we write them alphabetically, x, y. And there's our answer. Okay? And so that's what may be happening. So on your homework that I'm going to give you tonight, there's some where the matches are perfect. They have the same coefficient and opposite signs. So it's great, you just add. Others are going to ask you to multiply one equation by a negative to get that opposites, and then you can add and be done with it. Okay?